Today we're going to talk about segment relationships and circles, section 11.6 here. Yesterday, if you recall, we talked about angle relationships. So we talked about a lot of the angle relationships. Today, however, we're talking about the segment relationships. Who remembers part of the angle relationships? What was one of them? No, angle relationships in a circle, please. It was just like what we did in our warm-up right there. Okay, where you subtract the arcs and divide by 2. Yeah, that's what we talked about yesterday. Today we're talking about the segment relationships, though. So the first segment relationship is what we call the chord-chord product theorem. Okay, so chords, we know, extend from the parts of the circle, intersect on the inside there. So if two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. So what that means here is this chord cuts up into two parts here. I have a part there. Oops, right here. I have a part there and I have a part there. I have a part here and a part here. So those segments cut up, multiplied, equal each other. So for example, down here we have an example. I have a segment length of 4 and 9. So 4 times 9 equals 6 times x. 36 equals 6x. X equals 6. And you worked it out. That is what's called the chord-chord product theorem. Pretty straightforward, right? Yeah, it is. So let's look at number 1 here. Now, number 1, again, you should be able to work this out. But after a while, you should start recognizing this because it's a gimme type of an answer. Well, it's still going to set it up, though. What is the first segment here? Let's go with the one that's put together. So I have 7 times 3. And that's going to equal 3 times y. Now I work that out. 7 times 3 is, I get 21 equals 3y. Divide both sides by 3. And I get y equals 7. Now why does that answer make sense? Let's think about this. It's the same length. If these are the same, those have to be the same. Okay, and again, if you recognize that, it gets it pretty easy. Let's try number 2. Now to look at my chord, I have segments of 12 and 5. So 12 times 5 equals 6 and x. 6 times x. 12 times 5 is equals 6x. Divide both sides by 6. And I get x equals 10. There we go. Number 3. Set up number 3 for me. Trevor, how would you set it up? 6 times 5 equals 4 times z. 6 and 5, 4 and z. And then you work that out. 6 times 5 is what, Johnny?
30.
30 equals 4z. Divide both sides by what here, Gabe?
4.
And you end up with z equals what, Caitlin? 7.5. And the last one, number 4. How would you set up number 4? Jack, what are you saying? What's 8 times 5, Keegan? 16x. Divide both sides by 16. And I end up with x equals what, Drew? No. 2.5. Nice job. Alright. So is the chord-chord product theorem pretty good? I mean, it makes sense, right? Products of them equal each other? Great. Take a couple seconds here and try numbers 5 through 8 as they come up here slowly. There they are. Take a couple seconds to try these 4 on your own. Number 5. Nick Goldup. Number 5. What did you get for x?
1.
X equals 1. How did you get that, sir? 2 times 4 equals 8 times x. Is that right?
Divide by 8.
Good job. Number 6. What did you get for y to equal max?
7.
Y equals 7. How did you get that, Max?
Because it's 3.5 times 4.8 is 16.4 or something. Divided by 2.4 is 7.
Nice job. Number 7. Now, again, number 7, hopefully you look at it and you get the answer right away. Because what's the answer, Ryan? It is 7. How'd you do that? Because if those are the same, these got to be the same, right? Nice job. Number 8, last but not least here. Camden, what'd you give number 8? So Camden, what'd you get? Nice job. M equals 4.5. And you'd get that because 3 times 6 equals 4 times M. So you end up with 18 equals 4M. Divide by 4 and you get 4.5 or 4.5. Good work. All right, last thing we're going to talk about today is a little bit tougher. You have what's called a secant segment, which is a segment of a secant with at least one endpoint on the circle. And then you have an external secant segment, is the part of the secant segment that lies in the exterior of this circle. Okay, so for example, a secant segment is on the inside. So I get my drawing tool up here. So there's the secant segment. The external secant segment is on the outside. And then we all know what a tangent line is, right? Tangent's on the outside of the circle. So great. Notice, a little bit tougher here. When I have secants, okay, on a chord it was, hey, the chord times the chord equals the chord times the chord. On the secants, it's the whole length times the outside equals the whole times the outside. So the whole length would be all of this right here times then the outside equals the whole length times the outside as well here. So it's the whole times the outside equals the whole times the outside. And then a secant tangent is, yet again, the whole times the outside equals now the tangent squared. Okay, so recognize that. It's a little different. Okay, these are a little bit tougher just because there's a little bit more going on to it. So let's try number 9 here. I'm given 2 secants. How do I know they're 2 secants? Because I have 2 lengths for each of them. Now, for secants, it is the whole length times the outside length. So let's look at this first one here, number 9. What is the whole length of this top right here? What is the whole length of NQ? That would be whole length, 12. Because it's 4 plus 8, you get 12. So I have 12 times, what is my outside length? 4. And now I'm going to set that equal to, what is the whole length of my other secant? Ooh, it's not 6x, it's 6 plus x. Why is it 6 plus x? Because I can't multiply them, I'm adding them. It's 2 segments added together. So that's 6 plus x. And then I take that times, what is my outside segment? What is the outside segment there? It is 6. So I have 12 times 4 equals 6 plus x times 6. Now I need to simplify. Well, what's 12 times 4? So I get 48 equals. Now, what do you have to do when you have parentheses and a number on the outside? Distribute. So you get 36 plus 6x. And now it's just a 2-step equation. Solve for x. What would you do next? You would subtract 36. You end up with 12 equals 6x. And x equals 2. Okay. Recognize the difference there. A little bit tougher. Let's try number 10 here. Okay, let's do the bottom one here first. What is the whole segment of the bottom? 18 times, what is the outside segment here? 18 times 9 equals, what is the whole segment of the top secant? 8 plus z times, what is the outside segment? 8. Now I need to simplify it. 18 times 9 gets me, is that 162? Equals, what do you have to do when you have a number in parentheses? You have to distribute. So you get 64 plus 8z. And now it's a 2-step equation where I can solve. What would I do to solve for z here? First step, I would subtract 64. Nice job. Tom. Subtract 64 both sides. 162 minus 64, you get to 98 equals 8z. Divide both sides by 8, and z comes out to be approximately 12.25. Nice job. All right, now 11. This is a little bit different here. It's still the whole times the outside. So I'm still going to do the whole times the outside here. Anytime you have a secant, it's whole times the outside. So what's the whole segment there? 16. So I have 16 times, what's my outside? And now I'm going to set that equal to my tangent squared. What's my tangent? So I get x squared. 16 times 4 is? So I get 64 equals x squared. What undoes the squared term? Square root. So I take the square root of 64 and I get 8. X is 8. Good job. Let's try number 12. Number 12 is a little bit tougher. What is my whole segment here? 6 plus y. So I get 6 plus y times, what is my outside segment? Times 6 equals, what is my tangent? 9 squared, which is 81. Now I need to solve for y. Anytime you have a number in parentheses, you'd want to. So I get 36 plus 6y equals 81. Now I need to solve for y. What would you do next? Subtract 36. You get 6y equals 45, and then divide by 6, and y equals 7.5. Good work. Okay, and again, the biggest thing here is whenever you recognize a secant, something like this, it is the whole times the outside. All right. Take a couple seconds and try these four. You have secants and then secant tangents. Take a couple seconds, try these four. All right, number 13 here. Now, 13, you could work it all the way through. Otherwise, you could notice, what about this one? They're the same. So if they're the same, what's x have to be? 4.5 or 4.5. Nice job. Okay. Number 14. Walk me through how you set up number 14. Then give me the answer, Troy. How'd you set it up?
You set it up by, you add 18 or 9 equals 27.
And then take that times? Equals?
243. Oh, yeah.
And then what's that equal to the other side?
That equals 12 plus in parentheses.
Times?
12.
Nice job. So you end up with 243 equals 144 plus 12n. Is that right? And then you solve for that. And what did you get for an answer there, Troy? Huh?
1.5. Troy!
Max, what'd you get? 8.25. Thank you.
All right.
All right, number 15. How would you set up number 15, Ryan?
You would do.
I got
you
it.
would do. You add 9 to 5, get 14, and then multiply 14 by 5, get 70, and then you pretty much.
So 70 equals b squared, right? Then take the square root of 70. Does the square root of 70 simplify? No. So if you were to do radicals, you just get square root of 70. If you were to do a decimal, then it gets about what? Doesn't get about 8.3?
Right.
Huh?
It's like 8.27.
8.37. Thank you. And then 16. 16 is a little tougher here. Well, let's look at this. How would I set that up? Max, how would you set it up?
52 squared is equal to 26 plus z times 26.
Something like that. And then you'd have to distribute, right? 52 squared comes out to be, what is that? 2,708? Oh, 2,704 is close. Equals 26 squared, is that 676?
Yep. How do you do that?
Plus 26z. And then you subtract 676. And you end up with, what's that? 2,704 minus 676 is 2,000 what? Come on, somebody subtract them for me. 2,028 equals 26z. And then divide both sides by 26. And z comes out to be approximately what, Max?
78.
78. Nice job. Now, does that answer make sense for this problem?
Yeah.
Yeah, of course. Look at it. This segment's 26. This one's 52. Yeah, that looks like that's probably 78. That makes sense. Good work. Here's your assignment.
What?